Our next speaker is going to zoom from bugs all the way up to basically just the size of the universe. And if you've ever seen one of Schuyler's Ignite talks, you know that it'll be information-packed. So everyone hold on to your brain caps and be ready for a Gatling gun of ideas. Please welcome Schuyler Erle.
Now, you probably saw that video that came from Stanford last week, where the physicist Andre Linde got first word of experimental verification of his theory. And when they told him, he looked like he was about to faint. And this was kind of cool. I'm going to give you an idea of why you should probably faint too. Now, a century ago, back when we thought that the Milky Way was all there was, an astronomer named Vesto Slipher was examining these objects called spiral nebulae. And when he looked at their spectral nebulae, their spectral light spectra, rather, he saw that they were all shifted to the red from ordinary stars. And he reasoned that this was due to a kind of a Doppler effect. And we see the Doppler effect on a daily basis when an ambulance passes by. As the siren recedes, the tone gets deeper as the sound waves lengthen out over space. Well, the same thing happens with light. As a light source moves away, that light becomes longer in wavelength and becomes redder. So this is a kind of a strange result because it implied that somehow these spiral nebulae were flying away from us in absolutely every direction at speeds so fast that they should have shot right out of the Milky Way. So nobody really knew what to do with this result until about the 1920s, when Edwin Hubble and Milton Humason discovered evidence of certain stars in the Great Spiral Nebula in Andromeda that suggested that they were over 1 million light years away. And they went on to demonstrate that all the spiral nebulae were actually galaxies in their own right, outside the Milky Way. Now, they went on to prove that the galactic redshifts were real, and that the galaxies were shooting away from us in absolutely every direction at incredible speeds. Now, how could this be? Well, earlier, a Belgian physicist named Georges Lemaitre was examining the general theory of relativity, and he came up with an interpretation that said that space would just naturally expand in all directions at once, like the surface of a balloon. Even Einstein thought this idea was completely insane, which it is, but we have to accept Hubble's evidence, right? Now, either the galaxies are flying away from us because they hate us, or they're flying away from each other as well, which means that space really is expanding, and by examining the relation between distance and redshift, we can work backwards. And we discover that our universe must have started from a tiny point, 13.8 billion, that's with a B, billion years ago, in an event that we now call the Big Bang. That's pretty cool, right? So in the 1940s, one of the early predictions of Big Bang theory was that initially matter would be so dense that it would be impossible for light to escape. And we wouldn't be able to see anything from that time. Only later, when matter thinned out and light could travel across the universe, we'd be able to see it. But then it would arrive in our time as microwaves, stretched out by the expansion of space. And indeed, in 1964, scientists at Bell Labs discovered a persistent hiss in the microwave spectrum, in the frequency exactly predicted by the Big Bang theory. But Big Bang theory doesn't answer all of our questions about the universe. For example, why do we see more or less the same amount of stuff in every direction we look in the sky? It doesn't seem like the universe has had enough time to reach this kind of thermodynamic equilibrium. Another question is, why is space Euclidean, right? Why is the geometry of space Euclidean? It's not curved. Parallel lines don't meet or diverge in the distance. And if they did, apparently, galaxies wouldn't be able to form, or the universe would collapse, something. It's bad. Anyway, it's bad. But that's not what we see, right? So in the 1980s, Alan Guth and Andre Linde, remember Linde? Yeah? Andre Linde came up with this theory called inflation. And the idea was in the first trillionth of a billionth of a second, the universe could have expanded by 20 orders of magnitude or more. This would be like a baseball inflating to the size of the galaxy. And this would have the effect of smoothing out any curvature in space and spreading matter and energy across the universe in a uniform way. But the question is, how do you test a theory that concerns an event that happened billions of years ago in less than the blink of an eye before light was even visible? Now, we know that light can be bent by gravity. The general relativity tells us this. And inflation theory tells us that inflation should have spread ripples of gravity throughout the universe, like ripples in a pond when you drop, I don't know, the universe in it. We should be able to see the faint imprints of these ripples in the cosmic microwave background today. So scientists at Stanford built a microwave observatory, a very sensitive one, at the South Pole, right? And just last week, they announced that they found polarization in the cosmic microwave background, apparently due to primordial gravity waves that came out of inflation. I mean, it's no wonder Dr. Linde nearly fainted, right? This is a validation of his life's work and of an entire century of cosmology. In other words, we tiny creatures on our little planet seem to be able to stare off into the vast reaches of space and time to see the very first instant of time itself. Thank you.